Question 3 says, on comparing the ratios a1 by a2, b1 by b2 and c1 by c2 for each pair of equations, find whether the pair of equations are consistent or inconsistent. So let's first discuss the meaning of consistent and inconsistent pairs of linear equations. So a consistent pair of linear equations is any pair that has at least one solution, and an inconsistent pair of linear equations is a pair of linear equations that has no solution. Now, what does this mean in terms of the coefficients of the pair of linear equations? So let's go over the possibilities one by one. There are actually three possibilities, just like we saw in the previous question. So the first possibility is that a1 by a2 is not equal to b1 by b2, and in this case the two lines representing the pair of linear equations will be intersecting lines, which means that they will have exactly one unique solution. They will have one solution. So when a1 by a2 is not equal to b1 by b2, the system will be consistent. It will have a solution and it will have exactly one solution. The second possibility is that a1 by a2 is equal to b1 by b2 is equal to c1 by c2. So all the three ratios are equal, and in this case the lines representing the pair of equations will be identical. So the first and the second line will be coincident, which means that all points on one line will be common to the second line. In other words, this pair will have infinitely many solutions. So in this case also the pair of equations is consistent because there are infinitely many solutions of the pair. Now the third possibility is that a1 by a2 is equal to b1 by b2, but these two ratios are not equal to c1 by c2, and in this case the lines representing the pair of equations will be parallel. So because they are parallel, they will never intersect, which means that this pair will have no solution. So this pair will be inconsistent. So in the first two possibilities, the pair of equations will be consistent, and in the third possibility, the pair of equations will be inconsistent. So now let's apply these ideas to each of the given pair of equations that we have, and let's find out whether they are consistent or not. So the first pair is 3x plus 2y equal to 5, or I can write this as 3x plus 2y minus 5 equal to 0, and 2x minus 3y minus 7 equal to 0. So this is the first pair. Now a1 by a2 is equal to 3 by 2 and b1 by b2 is equal to 2 by minus 3. So these two ratios are unequal, so I don't need to check c1 by c2. So these two ratios are unequal, which means that this pair will have a unique solution. In other words, this pair is consistent. Now let's take the second part. And so in the second part, the two equations are 2x minus 3y equal to 8, or 2x minus 3y minus 8 equal to 0, and 4x minus 6y equal to 9, or minus 9 equal to 0. So in this case, a1 by a2 is equal to 2 by 4, b1 by b2 is equal to minus 3 by minus 6. So both of these ratios are equal because they are equal to half in the lowest form, and then so these two ratios are equal, and then we take c1 by c2, so that's minus 8 by minus 9, and this ratio is clearly not equal to half. So a1 by a2 equal to b1 by b2 not equal to c1 by c2. So the lines representing the second pair will be parallel. In other words, this pair is inconsistent. Now let's take the third part. So in the third part, the equations are 3 by 2x plus 5 by 3y equal to 7, or minus 7 equal to 0, and 9x minus 10y equal to 14, or minus 14 equal to 0. So what is a1 by a2? So that's 3 by 2 divided by 9. So a1 by a2 is 3 by 2 by 9 or 3 by 18. Then let's find out b1 by b2. So that's 5 by 3 by minus 10. So that's 5 by 3 by minus 10 or 5 by minus 30. So a1 by a2 is equal to 1 by 6 in the lowest form, and b1 by b2 is equal to 1 by minus 6 or minus 1 by 6. So clearly these two ratios are not equal, which means that I do not need to check c1 by c2. So the lines representing this pair will be intersecting, which means that this system is consistent. Now let's go to part 4. So in part 4, the two equations are 5x minus 3y equal to 11 or minus 11 equal to 0, and minus 10x plus 6y equal to minus 22 or plus 22 equal to 0. So a1 by a2 is 5 by minus 10, that's minus half in the lowest form. b1 by b2 is minus 3 by 6, so that's half again, minus half again in the lowest form. So these two ratios are equal, which means we need to check c1 by c2. So c1 by c2 is minus 11 by 22. So this is also equal to minus half in the lowest form. So all three ratios are equal, which means that the lines representing this pair will be coincident. They will be identical, which means that this pair will have infinitely many solutions, so it is consistent. Finally, let's go to the fifth part. So in the fifth part, the equations are 4 by 3x plus 2y equal to 8 or minus 8 equal to 0, and 2x plus 3y is equal to 12 or minus 12 equal to 0. So I just write the constant coefficients on the left side because that's the standard way of writing linear equations, ax plus by plus c in this form. So now let's find out a1 by a2. So a1 by a2 is 4 by 3 by 2 or 4 by 6. b1 by b2 is 2 by 3. So 4 by 6 and 2 by 3, these ratios are numerically equal. So which means we have to check the third ratio, c1 by c2. So c1 by c2 is minus 8 by minus 12, and minus 8 by minus 12 in the lowest form will also be equal to 2 by 3. So all of these three ratios are equal, which means that the lines representing this pair will be coincident. They will be identical, and that means that this pair has infinitely many solutions, so it is also consistent. So of the 5 given pairs, the first one, third one, fourth one and fifth one, these 5 are consistent, and the second one is inconsistent. So that completes question 3 of this exercise. To learn more about how QMath can help you crack school and board exams, explore QMath Leap, a live online classroom program run by highly experienced and committed teachers.